And then we can use this, and here's sine, sine 40 degree squared plus sine 50 degree squared. How to find this? Well, using the theorem we
Find
just learned.
62. Oh, okay. So find which one? A or B?
C. B, A, B, we
B.
did it.
Oh, C.
Yeah.
Sorry,
Yeah.
I can't see all of it because the bar is covering it. Sine
Yeah,
to the
yeah.
power.
Yeah, I just find the value of that because that's the
Oh,
proving
okay.
process.
It's on purpose.
Yeah.
Okay, so I guess this would be sine 40 degrees cos.
Oh, not those. We don't have a formula. We don't have a direct formula for this.
Okay, what's the formula for sine to the power of 2a plus sine to the power of 2b? Could you write that down for me?
There is one, which is sine x squared plus cos x squared equals to 1. That's the identity that I use most.
Oh, right. Oh, right. Yeah, that's silly. I forgot. Okay, so 1 minus cos. Well, where does that get me? Let's get 2.
Well, it's a kind of like a similar situation as before, right?
As which one before?
This is a sine square and sine square. This is a cot square and cot square.
Yeah.
Which is probably we should pause here for a little while because that there's no formula for that one. But the thing is, I can also say
Oh,
this part is identical as this part, right? This part is not in the right form, so I hope I can change this one into cos if possible. Does that make sense?
oh, okay. So we only changed one of them into cos. It makes enough sense.
So oh, not well. It is true, but what I'm saying is I want to make sine 50 degree equals to cos, which is a complementary angle theorem, cos 40 degree. Is it?
Oh, right. Yeah, we use the theorem. Okay, so so sine.
Yeah. And now it's at the same angle. So yeah, that's one, right? In the end, it's
Okay,
one.
yeah, that's easy enough.
Yeah.
Okay, yeah, got it. Understood.
So it's complementary. As long you complementary is using to simplify things, we use complementary. I think this one you already did it when you learned just how to use trigonometry, so we can skip all of this. All similar. Basic trigonometry. Will you learn bearing? Will you learn bearing?
Bearing. Oh, you mean the direction. Yeah, I
Yeah,
did.
yeah.
I think I did that in physics, but like I said, I haven't reviewed in a while, like I learned physics in 7th grade and that's
Oh, okay. Let's just take a look. So it's always with the, well, it's just the theta in when you travel in the sea with a navigation system, you kind of need a standard way so everybody understand everybody. So the typical way is using the north-south line, right?
Yeah. Oh, so you just do it. So the bearing would be like east of north or like.
Yeah, well, the bearing is just northeast line, and then find that acute angle. For example, if
Okay.
you're at
There.
OP1.
Okay. Okay. So the direction from. Okay. So the direction from like point O over there to point P equals the acute angle theta between the ray OP and the vertical line through.
Mm.
Oh, okay.
Which
Yeah.
means OP1 is just the bearing 30 degree east of north.
Okay, so the bearing is just like, yeah, okay, I see it. I see.
I can just say
Yeah.
bearing 30 degree from P1 to O. And then I can say OP, well, let's say OP2. OP2 is just with this acute angle, and so that's 50 degree, right? Bearing 50 degree OP2. Does that make sense?
Yeah, fifth bear is it wait, wouldn't are we sure it's not negative? It's 50 degrees west
Yeah,
and
or you can say, yeah, south of west.
south. Oh, okay, you mark it like this. F 50 degrees west.
Yeah,
Okay.
or I can just saying the bearing from O to P2 is 50 degree. And also from OP3, then it's just the north of west. Also, I can say the bearing from O to P3 is 70 degree, or I can say north, 70 degree north of west, right?
Yeah.
This is the bearing. Remember they used north, south line as an axis, and then use the acute angle to describe it. And using like east of north and south of west is bad. And then he asked 11. In figure 16, what is the bearing of O from O to object at P4?
Figure 16. Okay, P4. So O2 here. $130 degrees. I believe it's east clockwise. Oh no.
Yeah. So the bearing from O to P4 is, wait, they gave you already. It is, right?
Yeah. So I just minused it and then I like, from O here to P. Oh wait. Oops, it's not P1 to P4. Sorry,
Oh,
my
yeah.
mistake. Okay, so it's not 130 degrees after all. Okay, so well it's still easy enough. 90 degrees minus 20 degrees equals 70 degrees.
Well, that's one way to express it, but in bearing, we want to use this. So you just use that 20. You can just use that 20.
Oh, you just use 20?
Yeah.
But it's
Because
from O, so
your way is also a way, but this is standard way for bearing is like that, using
I
the
guess.
north and south. So it's south of east 20 degree, right? That's the bearing from O to P4, right?
Yeah.
So south 20 degree east, right? Does that make sense?
Yeah, okay.
And it's bearing. Let's do example 12. You have to draw a little bit for this one.
Okay, a bearing of n 20. Okay, so north, east.
Yes.
So 20 degrees would be around
Yes.
here, I
Yes.
guess.
Yes.
And then it turns 90 degrees towards the northwest.
Yeah.
So that would be here, but minus 20 degrees. So it,
Oh, wait. So they go 1 mile after flying 1 mile, right? So you go for 1 mile this, right? And then you
yeah,
turn 90 degree and head
yeah.
toward northwest, right? In this.
Wait,
Here's
oh, and
degree
turn,
one.
what do you mean? I thought it meant turn 90 degrees like to here.
Oh,
Am I
no.
mistaken?
Yeah. So you have to fly after flying 1 mile and you turn. You're turning in the beginning, but he
How do you
said
turn? How do you?
after flying for 1 mile in that direction, right?
I know. I'm just saying, like, how is he turning 90 degrees towards like?
Well, northwest is in this direction, right? This is north and
Yes.
west, and this is 90 degree, right?
Yeah. Okay. Okay. I guess.
Mm.
I certainly get it. Okay. Okay. So
Mm.
90 degrees, and then the plane goes 2 miles.
Yeah, that's right.
I guess. I guess the bearing would be like. I don't know. I don't know. Like
So
20.
so he said control
I don't know.
tower use. So this is a control tower, right? The beginning
Okay.
is the control
Yeah,
tower.
but I don't know. I don't know how far it's going to go after 2 miles. I can't really tell. I know it's flying for 1 mile, but like I don't
Yeah,
get it. Sorry.
it didn't really ask, but that's a good question. But the question is now he's asking the control tower, which is here, and locate the aircraft, which is here, and basically using what bearing is basically using as before. This is O, this is a P. He's asking what from O to P, what is the bearing basically? Does that make sense? That's why they say, what bearing should the control tower use to locate the aircraft?
Yeah, okay.
So
Oh,
basically,
okay. So then it
this
would
way.
just be like here. Okay, so it would be like theta and
Yeah.
then but how can we tell what theta is?
So we have so the closest thing that I get is a 20 in here, right? And then we have 1 in here. We have 90 in here. Let me get this out. We have right now, this is 90, right? This is 90 degree. And this is a 20.
Yep.
So if,
Oh, so the
right?
other one would have to so the other one it would have to be 70 degrees. So it's like
I don't really know. I have to
oh,
find it with 10. 10.
sorry.
This big one. This is the big one. Let's say it's
Oh wait,
X.
yeah, because it
Or
has
1.
to be like 10, 2/1. Okay,
Yes,
so
yes.
here is 20 degrees. Am I mistaken?
Yeah,
So
that's
here and then here it's 2, or it's all of this 2. I can't tell. I don't
yeah, this is
really
2. You
get it.
see, you turn
Oh,
after you
okay.
turn, you
So
go to
2
1.
and then here is 1.
Yeah.
Yeah, I'm kind of getting it now. So
Mm.
then 1, what would be it for here? Okay.
Mm.
Mm,
Making it bigger, would it be something
and
like
here.
this?
Here.
Mm.
Okay, so you go up like this, and then you go there, and then over there. Okay, so how will we find the angle from this? I still don't really get.
I find the right triangle is the good one. So I can find the total angle for this one, which is saying this is X. So it's 10X is 2 or 1. So X is 10. Inverse function of 10 is 2. go for calculator to get this. So I can find this angle. Does that make sense? I can find this angle totally, this big angle.
Oh, okay, you need to find this big angle first,
Yeah.
and then you have to find the other ones. Okay,
Yeah,
so
then,
part of it is 20 degrees and part of it is the theta.
yeah.
And we need to find out what theta is.
So I can use the big angle minus 30, minus 20, right?
Yeah, okay.
Hmm.
So tan equals, so x equals tan minus 1, 2. Okay, let me, tan, arctan 2.
Yeah.
It's like 1.10714872 radians.
Oh, yeah, you can change it into degree maybe. I think they probably want a degree to use 20 degree. They probably don't have to use degree in bearing.
Okay, yeah, it's like 63.4349488 degrees.
Or
Just say
minus 20,
63.4.
yes, minus 20. Then it's 43.4 degree, right?
63.4.
Hmm. Does that make sense? So I can, well, as the control tower, this is how you locate the aircraft. You know, if you want to
Wait, okay. What did you write? C340 minus 20?
no, this is
I can't read
63.
that.
I just wrote what you just said.
63.4. Oh,
Degree.
okay. Yeah, sorry. Sorry, I didn't really read that. Okay. Okay, yeah, okay, that does make sense. So 43.4. And
No, that's the theta.
yeah, okay, so then if that equals, and here I guess it would be 1. It doesn't matter though, like if 63.4, so I guess if we do 69, so we do 180 minus, oh wait, we actually don't know the other one. Never, wait, okay.
This,
Oh, oops.
this is the answer, I think.
Oh, it is. So
Yeah.
so this is. Oh, right. Yeah,
This is the
yeah. Sorry, I
bearing.
forgot. I was like, I need to calculate the upper angle, and then I
Mm,
forgot the bearing was like from there.
yeah.
Okay. Yeah.
This is the bearing. Let's see. So the bearings, the control tower used to locate is, well, 43.4 degree from, well, this is for the aircraft, from O to, well, what's that location? I don't really know. From O to the aircraft, right?
Yeah.
Hmm. Oh, this one we learned bearing. Just need bearing in the, yeah, complementary theorem. So leave for one. Okay, this is the little homework, page 513. From 19 to 22. 19 to
19 to
20.
22. Okay.
And
Homework already.
yeah,
Page what now? 19 to 22?
513.
22, 19 to 22.
Yeah. And this is just don't forget this, not using calculator. You're using like the theorem, complementary theorem.
No calculator.
Yeah. And they
For
have
those do we have any other questions?
yeah, a little
Or no?
bearing. Yeah, a little bearing question then.
Yeah, okay.
Bearing. 63.
Page
Later.
63. Oh, question 63.
Yeah, question
Still on the
63.
same page.
Same page. Or the next page, same page, the next page. It's all
63 to what?
just 63. That's a big bearing
Okay, yeah,
question. Same as
63. Okay.
similar as the example. And we finish this one, then let's... Have you learned law, like a law of sine? Sine law, cosine law, sine law. Have you learned sine law?
I don't think so.
Like this. Let me show you. It's this. Have you learned it?
Oh, sine. Oh, I don't think so.
Okay. And we can take a look. This is all the one that we want to. Let me prove one of this actually. Let's just use any triangle. ABC. Not special angle. It's just normal triangle. Doesn't have to be any special angles. So I can find the, let's use the height to prove it. So what if I want to find the height here? This is ABC.
Then I guess you, I don't,
This
sorry,
is the height.
it's been a while. It's been like a while, but I guess you would.
Let's just say this one is, since they use ABC, let me just mark, this is D, like capital letter D. And so this one would be called A, right? This entire thing would be called A. This entire thing would be called B, right?
Yeah. And then like the
this
other side would be called C.
C, yes. And how to find the height? Let's say the height is just AD. So the height AD can be found in triangle ABD. In the triangle ABD, I can find it use, well, since they have sine A, sine B, sine C, so it's probably wise to use the angle. So I'm using, mark this one as sine B. So sine B for that one is
so
AD
sine B over B. Oh,
C,
okay.
right?
Equals AD over C. And just to clear, yeah. And A and AD is here.
And then sine C.
And C is here.
Yes,
and equals. Yeah, it makes sense. And sine C equals.
Sine C equals to.
Let me try to figure this one out. Equals up. Okay, so it's also D over B.
Yep. And then we have AD.
I don't really think it all lines up, but I think it kind of does make sense, like with like the formula. The variables don't all line up, but it makes sense.
Yeah. So AD in both equations. So AD equals to, for this one, AD equals to sine B times the C, times C, right? Times C. C times that. Does that make sense? And for this one, AD also equals to B times sine C, right? Just time it, right? B times sine C.
Yeah.
And so since AD both equals to each other, so it's C equals, C times sine B. C times sine B equals to B times sine C, right? Does that make sense? They're both equals to AD, right? Does it make sense?
Yeah, that does make sense because like it's like the river. Okay.
Yeah, and then I can change the form in there. So I'm moving this B in there. So it's sine B over B. And this side, it's sine C. I put it there.
Oh, wait. Okay.
Sine C.
Sorry, I thought you were just
over
switching
C.
up I thought you were just switching up the variables for some reason. Sorry, I was under the impression that you were just switching out the variables and like C was meant to be B or whatever, but you just didn't do that for some reason.
Is that making sense? Divided
Okay, yeah,
on
hang
both
on,
sides.
give me a second. I need to reevaluate
Sure.
based on my new knowledge. Okay, C times sine B. Okay, equals AD, both equal AD, so AD equals B sine C. So then they both equal each other because of like that one law or whatever. So then, yeah, that makes sense.
Yeah. So now if this is working, So remember sine B or BC, I pick it randomly, right? So this must be working in three kind of ways. I mean, so eventually I must have sine A over A equals to sine B over B, and then sine B. Well, if they equal, then that's altogether this one is working, right? I can just expand this concept, this theorem in here. Same proving process basically. Does that make sense?
Yeah, okay, yeah, of course. Yeah, it makes sense. There's like AD and like probably sine A work for the same reason.
Yeah.
And
It's
yeah,
basically
it's just a bunch of information being built on top of each other, I guess.
yes.
That is kind of why I wanted to review the formulas, but I guess it would just take too much time. I don't know, it's just I feel like sometimes I just don't really get like the reasoning behind the formulas, but it takes too much time to ask and then I feel stupid, so then I just like move on and like try.
Yeah, it's hard to keep the balance. Some like about all the like intellectual power like for math, some of them like to write the process, and some of them actually, in order to give us a better view for the whole picture, they don't write the process. It's hard to say which one is right.
Yeah.
So anyway, it's kind of making sense, right? If it's kind of making sense, then I would just
Yeah, this one is making sense. I was just thinking about like formulas in general. This makes sense.
yeah. So if this one is working, so all this is working, right? So we can use some of them to do some questions. Let's see. Use this. This is called sine law or law of sines. For example, here, example 1, solve the triangle.
Oh, okay. Right angle. Yeah, we need to remember this again. Let's say this is A.
Mm.
Okay, so okay, sine. So then sine A is sine 40 degrees, which is sine, not sine, okay. This one's pi over 3 at least, so it's simple. It's B, whatever B is, God.
Where is calculator?
How do I even assess? Okay, I'm gonna look up what sine 40 degrees is.
Yeah, it does we need calculator for sine 40. There's no way you will know that.
It's like 0.64, I think. Oh, that one. Oh, across from it. Okay, so A is the one across from it, right?
Yeah.
Sorry, I'm trying to. Sorry, I keep forgetting that these things are supposed to be across from each other. Okay, so 4. Okay, so 0.64, I believe, over 4. B. Okay, so 0.64. Let me.
We can use decimal for that one
0.16.
too.
16. Okay, I gotta look up square root of 3 over.
Yeah. Or we can just write like use a calculator to get sine 60 in decimal. We're getting decimal anyway.
It's like 1.22 or something. 1.22 over b, which okay. I'm like kind of round estimating here. So.
Wait, you should use.
Wait, oops.
Oh. It's 1.7 divided by 0.16, yes.
Okay.
It's really more than
Okay, it's around 7.65.
Oh,
And then
7.
C is whatever it is, I guess. Oh, wait, C would be 60 minus 60 degrees minus 40 degrees, so it would be 80 degrees.
Yeah.
So sine 80 degrees, okay.
What I feel is a little different on this one. Oh, B here. He said it's 5, right?
Huh?
A little bit around 5.
I was trying to.
I think the
Oh.
process is right. It's only about typing on the
Yeah,
calculator.
I think the process was right. I think I got some steps wrong a little bit, but like I think the idea I was trying to do.
Just typing in the calculator. 4 times sine 60 and over divided by sine 40, and you substitute. I guess it's a calculation, right? So it's at around 5, right?
Yeah, we do. Yeah, okay. So we times 4 and then so 4 sine 6 so then 4 sine 60. Okay, so hang on, let me do the steps. B sine 40 hang on, let me clear everything first. Okay. B sine 40 degrees over 4 equals sine 60 degrees.
Yep.
Yeah, and a similar thing for C, where C sine
80, 4 sine 80.
yeah, that's basically C equals. Yeah, I think I just like trying to like do the step differently,
Yeah.
and then it went wrong.
But this is okay, right?
Yeah.
And for example 2, well, that'd be similar too. To solve all the sides and all the angle with sine law of sines. Example 2 is okay? Is it okay?
Yeah, okay, and now we need this one. So I guess I'm not gonna draw for this one. I'm just going to like.
Sure. If you find that very similar with basic, it's good.
Never mind. I said I wasn't gonna draw, and then I immediately decided to draw. Oh wait, I guess A can't be. Okay, so A can't be the hypotenuse, so it has to be C. C here. Oh. I'm glitching weirdly. Okay, whatever.
Very similar.
Okay, so this one equals 5. So here, A would be like 35 degrees. B is like 15 degrees. equals, okay, so B, okay, so it's like sine C over 5 equals sine 35 degrees over A. Let me just try working with this. Okay, so 5 sine C equals 5 35 degrees over A. Okay, A sine C.
Angle C we can calculate, right?
Oh yeah, okay, just give me a second. Just give me a second to like work it all out.
Mm.
Oh, I'll need to figure out what the time is gonna be. Oh wait, we can tell what sine C is. I feel kind of stupid. Okay, so 15 plus 35 is 50 degrees, so
And then that's
oh one wait, no, 35 plus 15 is 50, so 130 degrees.
130, yes, 130.
Yeah. Okay, yeah. Let me just put let me just calculate it. Do a calculate.
Yeah.
5 sine 15 degrees over sine 130.
Mm.
It's like 1.689. I think it's B, right? Okay, yeah, it's B. Okay.
169. Yeah, 169. 1.69.
89. 89 and okay, and then this, and then sine A. Around 3.74.
Yeah.
Okay, yeah. And yeah, that's about it. We could probably figure out.
Yeah. The rest of it is kind of similar. Well, it's just well, this is a way of simplifying, which means when we draw a triangle, there are so many triangles in life, we don't have to try all of them. So for example, you got a 35, you got a 15, you got a 5. The rest of it is certain. Does that make sense? Well, we don't have to check all the way. You make this 3 right, the rest of it just follow.
Yeah.
So it's kind of similar. I'm going to skip example 3, right? Just use the formula. Get all of them basically, right?
Yeah.
Sometimes we are struggled with whether there's one solution. You can see that there's one solution. Sometimes there are more than one solutions. That's why they put it here instead of just skipping. Let's do two solutions now. Let's just do 4. And we have 2 possibilities. Just do example 4.
Okay, example. So again, okay. Oh wait, 6 to the power of 2 plus 8 to the power of 2 equals.
Wait, why did you? You can't really know it's 90 degrees. Are you using Pythagoras?
I'm just guessing what C is.
Oh, well, I think we kind of have to get C ourselves because they didn't really say it's Pythagoras. They didn't say it's
Yeah.
90 degrees.
Okay, well, I don't really have that much to go off of. I'm trying to guess here. Sorry.
Well, it's okay. 6, 8, 10 is a very popular though.
Okay, whatever. I'm gonna find sine 35 over 6. I'm gonna calculate that.
Mm.
0.096 actually. Oh my god, Catherine, I'm busy. I'm doing class.
This is sine B, right?
Yeah. Okay.
Mm.
And
Sine B basically is 8
okay,
sine
sine B
35 right over 6.
is approximately 0.76.
Mm. Okay, that means 0.76. Good.
Yeah.
And then we do inverse, right?
Beg your pardon?
We do inverse to find angle B, right? Because you have sine B, it's probably a good
Yeah,
opportunity to
oh
find B.
yeah, okay. Sorry. So I was like inverse what? I sorry, it's fine. I'm kind of distracted. Like
Okay.
someone my family's talking outside.
Oh,
Okay, yeah.
okay. Sine inverse. Then invert sine for this.
Yeah, okay, let me reverse it. Okay, arc sine 0.76. Okay, that's approximate. Okay, that's approximate. B is approximately 0.86 radians. Do you want it in degrees or?
Yeah, probably in degree.
Okay, it's 49.46 degrees.
49 point
49.5 or something.
5. It was 49.5. Oh, here is a thing. When we do inverse, now we have to use something we learned in trigonometry. We normally say you have to give me an interval, otherwise there could be so many solutions, right? Remember?
Yeah.
So for this one, B is between 0 and 180, right? Does that make sense? I mean, the interval is, without saying, is between 0 and 180,
Yeah.
right?
Yeah,
So
of
this
course.
is one solution. So there
Oh, okay,
might
okay, yeah.
be
And
another,
then
right?
you and then you just
Question.
minus it and you
Yeah,
reverse it
180
for your
minus that.
C.
Yes, 180 minus that.
Okay, hang on. Give me a second there.
Wait. Not exactly this.
Oh my god.
Not this. Not there yet. I'm talking about B. There is two kinds of B. So B1 is that. There's a B2.
There's another one? Okay.
Yeah, because you
Sorry,
see, this is 1, this is 0, and this is 180, right? So of one, like sine 0.76, there is two solutions in here in this interval, right? Or use your union circle. You can use a union circle. The
oh
union
yeah,
circle.
because the
This one
intervals
is
work.
this. Also,
So it's
that
like
one works,
around
right?
here
Yeah.
and then here and then I can't really tell because I'm like not I usually do in radians, but like I guess it'll be
Uh,
like less.
so 180 minus that. One would basically is 180 minus your 49.5 degree. This is your B2, which is possible. Does that make sense?
Yeah, okay.
And it's a little confusing. So we normally, for the first time, we normally check a little bit. So let's draw a little bit, see whether it's making sense or not. So basically, if I draw it, I draw the first it tell me 35 degrees, saying the 35 degree. And one of them is 6. Who is 8? Let's say this one is 8. And when the 6 comes in, I could be, this one is a 6, right? And this one could also be a 6. And the both of them satisfies whatever it described, right? So I guess it's working. One is this, the other one is this. You have 2 degrees there. I mean, 2 degrees there.
Yeah, I guess. So like,
Does that make sense? So the geometry also
okay.
checks with these 2 possibilities.
Okay, yeah, but like so okay, yeah, so how do we know which version to use?
Which one?
Which version to use?
Both of them. So that's why this is a 2 solution kind of sine law. In some sine laws, there are
Oh,
2
okay.
possible
So it's
triangles that we can draw.
either
Yeah, both of them are working. And we don't have enough reason
okay,
to
hang on, let me
eliminate.
try to do the 180 minus 35
Mm,
minus 180.
mm.
Okay, that's around 19. Wait. No, there's a mistake there. Oh yeah, I put 280 instead. Oops.
Oh.
Whatever. 95.5 degrees.
Mm.
And let's find the other version.
Let me check the data here. Oh, 7, 6. Yeah. He said B1 is 49.9. Or just calculation.
Other one is like 14.5 degrees.
Yeah. Well, it's a little close, I guess. It's just be careful with the calculations. The whole process is exactly the same. So is it making a little sense about two solution? Two solution is tricky in the beginning.
Yeah, okay, so either this or that could work. But I feel like the other one isn't like that likely because I feel like I don't know, I feel like for 14.5 degrees is a bit of a thin angle for a triangle. But maybe I'm thinking maybe sorry, okay, yeah. Okay, yeah, fine, it works. I guess.
And well, that's the key for this one. The new thing for this question is they come in with two solutions, especially when you get sign as positive in 0 to a 180 interval. Does that make sense? You can try to remember this graph. I love this graph though.
Yeah, there's like this several there's options. Not
So is that making sense about this solution? Of course, we have to find, when we find all the angles, we can find the last size of that, right? We can find there's
yeah.
A, there's B, there's C. Just using that one is similar as before, right? Does that make sense?
Yeah, that makes sense. Sorry. Yeah, that makes sense. You know, like there's several options there.
Yeah. And also I can draw it to check. So just remember there are two solutions sometimes. This even happens in SAT. Two solutions with, well, because you have sine positive, you have two solutions, 0 and 180. Oh, eventually they draw it, the complete one. See, this is one possibility, and that's the other possibility. And both of them can be drawn, so I guess it's okay.
Yeah, both are possibilities.
And we don't have enough information to eliminate either one of them. So we keep both of them. Of course, because they have different shape, eventually you have different C, right? This is one smaller C, this is one greater C, right? It's long. That one is longer.
Yeah.
See, and well, of course, before that one, the one that we skip is the one solution. Then that's okay. When we don't really have other choices, then that's the normal solution. And there is one. This one is called. Let's do example 5, which is a little different from one solution or two solutions. Let's do example 5.
Example 5. Okay. Oh, wait, if it has no solution, no one has to be
Yeah,
solving.
this time is no solution when you try to do it. You can just fill it in.
Sine 50 degrees over 1 equals sine A over 2. Let me calculate sine 50 degrees.
Mm.
Okay, 0.766.
Mm. This is higher than 1.
Equals like 1.5, 1.53. Sorry, not 0.
Mm.
Okay, and then arc sine 1.53 in degrees.
Error?
1 point what?
Is it? I mean, is that computer shows error?
Error?
Which means it can't be done, right? If you inverse that, it
Yeah,
can't
it
be.
can't be done. Oh, yeah, it has to be between -1 and 1. So outside of the
Yeah,
domain.
so that one is out of the picture. So this is the
Okay,
solution.
so no solution.
No solution,
Yeah,
which
but
means you.
it's important because it has to be out of the domain. Or
Yeah, and which means if you draw it, you can't draw it basically. Yeah, for example, if you draw, normally we draw a 50-degree, and you draw, let's say you draw this one 2, and you draw another one 1. You see, this one is 1. Actually, you can never, hopefully, it's you intersect with this. If you have 1 in here, there's no way you ever intersect with the with this. So there's no triangle can be drawn in this. Okay, that's this one, no solution. Well, so many apply problem. Let's just do one. Only do one. Do one.
900. So just okay. B over opposite hypotenuse. So C. Okay, and sine. I don't think I can really. Oh, I guess 900. So I guess the 9 is adjacent to this. What I'm gonna call 900 plus
35
equals. Okay, one of them is 90 degrees. So Guess sine 35. Guess if one of them equals 1 then. Oh, wait, let me think. I put like equals 1 because like 90 degrees, like sine 90 degrees over phi should be like sine 90 degrees over is like should be like it's like phi over phi divided by phi, so that's just 1.
So
Okay,
eventually,
so then
one. Which part is
eventually
one?
what?
One. We have 900. Are you using which triangle are you using? The A, B, C, A,
I'm
B,
trying to
C.
use this. I don't know. Oh no, I'm sorry. I'm sorry.
This is the first time we're dealing with that. Basically, they have 3 triangles, right? And
Yeah.
the key here is finding this height and then plus 2, right? And well, we have 35 degree, right? If only I know this length, right? Oh, we
Yeah.
mark it C. If I know this length C, but it's a little difficult to find it in here since we don't really know, anything in here. So the more things we know is actually in this 900 thing. It's probably, here's A, what's this? Oh, I don't really. It's probably better to, because we know more about this triangle. Other triangle, we don't know the length, right? You know what I mean? So we might want to focus on
Yeah.
this. We focus on this triangle. Again, I only have to try out to find that. I have to try out because this
Okay,
one
you
I
have to try
know.
out. Okay, so here this one is like B. Is it B?
Well, it's okay. You can use his, you can use yours. It doesn't really matter.
Could you show me like the red graph that you did again?
Oh, this is this graph. Because this graph we know more. We know angle, right? We know the
I know.
length.
I just want to see it. Yeah, I just want to see what you said. I just want you to like reverse it and I can see it.
So this is the one, right? This is the one that I chose.
Okay.
I know 90. I mean 900. And I also know this angle.
Okay,
And
900 this angle, and then that's okay,
that
47
one,
degrees. So 90 degrees
yeah.
minus 47 degrees would be like 43 degrees, and then we can figure that out through that. And then 900 meters
No.
is
This is 133 degree, right? Oh, you mean this one, right? Wait, I can use this one. I
oh yeah,
can,
133. Sorry, it adds up. Sorry, it adds up to 880
yeah,
degrees,
180.
not
Yes.
okay.
So in this one that I choose, there's 900. There's 133 degree. There's 35. Well, 35 probably doesn't really work in here. How about I know this one? That probably is good because I can use 900. Yeah, 12. Yes, 12. 12. Yeah, good. 12. Yeah, in this one, I think we can know more.
Yeah, and then like through that 900 somehow okay, so there's like 900 and then there's okay, so
So you mean sine, right?
I'm trying to
Sine.
relate it to this.
Uh, if you relate it to that should be 12, right? The one that you calculate 12. That's the opposite.
Okay, I was writing cosine. Okay, whatever. Sine 12. Okay,
Yes,
sine
sine 12.
12 over h, I guess. And then how do we, and then like,
Are you,
okay.
are you using a formula deduced by that one? The original formula is what? Is the sine over the length. Sine
Oh,
12
sorry.
degree over
Sorry,
900.
I sorry, it's okay, sine 12 degrees over 900. Oh yeah, we have to work with that. Sorry, I was thinking about like what sine equals, like sine equals like
Oh.
opposite over hypotenuse. I was thinking about
That is the law of sine law.
plus sine 90 degrees over c plus
Wait, this one is what degree?
133.
Oh, yeah, so this one is
I was
133.
referring to like here, like the overall triangle.
Oh.
What do you mean? Oh, you're right. Yeah. Okay. So yeah. Sorry. I'm just trying to piece it together.
I'm finishing the sine law. I'm using this. We finish this one.
Okay. Yeah.
Oh, you're thinking about the right triangle, right? Yeah, that's the next step. Yeah.
Yeah. Sorry. Sorry. There's just a lot of stuff going on.
Yeah. This is a very typical question. I didn't really get it the first time I saw this. So we can use the sine law, put this one in here, right? Sine 133 over c, right?
Over C. Yeah. Oh, yeah. And we can calculate all that.
Yeah,
Also,
now
it's 8:39. So do we have any more homework? Sorry. I
sure.
think I kind of get like the idea of it. We
Yeah,
can
just get the
work on
c.
more.
Yeah, get the c, and then you
Yeah.
can get the height, right? Then that's everything. Just
Yeah.
plus it through.
Get
So
the
that's
C. Get the
yes.
okay. I wanted to look at whatever. What homework is there?
So one sine law and two solution, one solution. Okay. This is page 525. 25 to 26, 25, 26, and 36.
Yeah. Sorry if I'm kind of out of it today. Like I just started like a really long camp. So
Yeah. And you also get the sickness, right? And so the other one is 41. 25, 26, 36, and 41.
25, 41. Okay.
The airplane thing. 40. And if you still want it, it's actually there's 39. You can finish the example that we did, actually, which is almost the same thing as 39. Okay. Do you have other questions?
Yeah. Thank you. Bye.
Have a good question. Bye.
Yeah. Bye. Thank you.
Thank you. Bye.